Welcome everyone. Today we'll explore how to unlock secure networking using Consul capabilities. My goal is to help you understand why traditional security models no longer work and how we can secure modern applications with Consul. But before we dive into details, let me introduce myself. My name is Ali Tlili. I'm a cloud and DevOps consultant. Over the past 18 years, I have worked with organizations worldwide to build and secure their infrastructure, automating workflows and enhancing security. Today, we're going to explore how Consul enables secure communication in modern infrastructure. But before we dive into how, let's take a step back and ask, why do we need even new security models in the first place? The why is the shift from static to dynamic infrastructure with the emergence of cloud and Kubernetes. In the past, infrastructure was a static application run in controlled environment, typically within a single data center. Communication between services was straightforward, and security relied on a perimeter-based model where if you are inside network, you were trusted by default. But today, that's no longer the case. Applications are highly dynamic, they scale up and down, they're running across multiple cloud provider and hybrid environments. Also, Kubernetes cluster. Services need to communicate across those boundaries, often over public or untrusted networks. The traditional security models, trusting anything inside the perimeters, fails in this reality. Once an attacker breaches the perimeter, then they can move and intercept sensitive data. This shift in the infrastructure demands a new approach to security, one that prioritizes secure communication. Every interaction between services must be encrypted, authenticated, and explicitly authorized, ensuring that data remains protected in the transit. And this is where actually Consul comes in. But this is why we need the new security model. But let's start with explain what is the old security and what is actually the new security and the better security model that we can have. In a traditional security model, organization relied on perimeter-based approach, like medieval castle. You had firewalls, network segmentation, and VPN allowing user in. And once you are in, you are authenticated and you have the broad access within the system. However, as the businesses moved to cloud and services expanded, attackers found new ways to exploit this static model. A single breach means a complete compromise. So what does a better security model looks like? Instead of a castle thinking in airport, you don't get to full access just by passing security at the entrance. You have multiple actually checkpoints where you are validating your identity. Your identity. And this is actually kind of starting from the beginning of the process until the end of the process. And only verified travelers can enter a specific area, and security continuously check people luggage at every step. And here we say check people because even like there is a traveler, but also there is the inside actually worker, which is the employees. Every access request must be authenticated and authorized and continuously monitored to minimize risk. And this is actually drive us to authenticate and authorize every request at every time. Secure service communication require continuous verification. Being inside the network, it doesn't automatically grant you services must authenticate and authorize dynamically at every step. Let's break down the core principle of secure access and service-to-service communication and explore how HashiCorp enables them through service discovery, service mesh, and CTS, Consul-Terraform-Sync, that we will explain by the end of the talk. But before that, let's see how actually HashiCorp enable identity-driven controls. By identity-driven controls, here you see like the shift is the shift from the old model to the new model is not like AP based or actually perimeter based, it is identity based. Is the unit of control is shifted from, let's say, from an IP address to actually an identity based. And like to enforce and secure access at scale, we need that identity driven security controls. And HashiCorp has with 3 different products. Vault to manage machine authentication and secrets and ensuring that credentials are securely stored and rotated. Boundary provide dynamic identity-based access for human user without exposing credentials. And finally, our console so that secure service-to-service communication, ensuring only authorized service can talk to each other. Right now, we're gonna zoom to console and how actually enable secure and scalable communication. Consul is a multi-purpose networking solution that helps organizations manage and secure dynamic infrastructure at scale. It enables three core functionality: service discovery, service mesh, and network infrastructure automation through Consul-Terraform-Sync. Like the three core functionality is actually are actually provided by Consul as a networking solution for modern application. It provides actually service discovery that helps services dynamically find and communicate with each other without relying on fixed IPs. It provides actually service mesh that secure service-to-service communication with encryption and identity-based policy. And finally, network automation through Consul-Terraform-Sync that for automate firewall rules, load balancer, any infrastructure update based on real-time service changes. We'll explore each one of those in more details, but we will start service discovery, which is kind of the base that rely to build like the new security model. In modern environment, secure services are constantly scaling up and down. Consul provides real-time service discovery, allowing application to dynamically find and connect to each other without hard-coding any configuration. Instead of relying on static IPs or manually updating configuration, service registers to Consul and it keeps track of their health and location. This is simplified the deployment, reduce the failures, and make service-to-service communication more reliable. The fact that we have a register for all the services is kind of actually enhance that security, and also the fact that service discovery is highly available and is not actually IP based. Like we don't have to do any manual introduction. That actually pushed to the automation, and it's really one of the security enhancement in the new model. In the traditional approach, before we dive in secure answer what is the service discovery and what is the service discovery with Consul, let's first understand how application communicate traditionally. In a typical setup, we have an application that need to connect to database. To make this happen, we assign an IP address to both services and configure a firewall to allow traffic in specific port. This approach works well, but when we scale, it becomes difficult to manage. Imagine we're running in Kubernetes environment where new application pods are constantly created and deleted. Every time a pod IP change, we need to manually update the firewall rules. The more we scale, the more complex it becomes. What if we had a better way to handle this in an automatic way? This is where Consul comes in. Now, let's see how Consul change this and solve this problem. With Consul service, don't need a fixed IP or firewall to communicate. Instead, they register themselves to Consul when they start. Every service that is gonna spin up is gonna register to Consul. Web services, let's say, announce itself, hey, I'm a web service. Database is gonna do the same. Any service that have the configuration, it will register when it start with Consul. And rather than actually relying on an IP, service security Consul to discover each other. If the web service, let's say in this example, one needs to connect the database, it simply will ask a Consul, hey, what is the database? What are my database? And any services will ask actually Consul how to reach out to the other services. Consul will return a service name, and actually the two service will be able to communicate without need to worry about any IP changes. And here, if like the service in Kubernetes or non-Kubernetes that change an IP, we don't actually worry about it. It will be always the same name. This is solve the scaling problem, and no manual updates. And no manual updates is enhancement in the security itself. Like it's automatic, and that automation probably is kind of near real time. But what about security? Service discovery and what is missing. Like let's summarize here, and actually we can explain the service discovery and what is missing. Let's summarize it. With Consul service discovery, service can register dynamically, make it easier to find each other without relying on static IP or manually updating firewalls. It also provides health check, ensuring traffic is only routed to the health system. However, service discovery alone does not enforce security. Right now, any service can freely communicate with any other service. All the traffic is encrypted. There is no access control, no authentication, and no encryption. That's where actually service mesh comes in. It adds the security on top of the service discovery. And that's why I said that service discovery is the base of the security model. And service actually mesh add the security by introducing intentions. This will be explained in the service mesh actually section, and mutual TLS for communication, for encryption and communication, and fine-grained policy to control who can talk to what, who can talk to whom. And so while service discovery helps with connectivity, service mesh ensures secure communication. And next, we will see how service mesh solves this security gaps. Service mesh is like a traffic controller for your services. Instead of a long free communication, it adds security, observability, and reliability. Now let's see why we need the service mesh and how Consul implements it. Many organizations rely actually in monolithic application where all functionality bundled in a single code base. And this is how the traffic flows in. Requests come from an external network, pass through a firewall and the load balancer, and reach out to monolithic application. The application then communicates with the database. This approach actually has a serious challenge. First, it relies on static IP, and the static IP is not one of the identity actually aspect of for the new security model, which make it difficult to scale efficiently. Second, scaling means duplicating the entire application, even if we need to scale one small functionality. This is kind of resource heavy efficient, and actually also it requires kind of a manual configuration since we're still using that IP addresses. Finally, a failure on one component can bring down the entire system, leading to downtime. At the same time, any breach in one component or any compromise in one component, all the application will be compromised. So how to fix that? Instead of relying on monolith, we move it to service-based architecture using microservices, which actually service mesh will improve the scalability and reliability and security. Let's see how it works. Rather than relying in a single large application, we break it down into smaller independent services that communicate with one another. Each microservice is responsible for a specific function and can scale it independently. This approach offers several benefits. Independent scaling, only the services that require additional source need to be scaled rather than the entire application. Failure isolation, if the single microservices have an issue, the rest of the system remains operational. And technology flexibility. For each service, you can utilize best suited database, best actual programming language, or any best, let's say, caching, Redis or something. However, while microservices address the limitation of the monolithic architecture, they introduce also new challenges. It's the increase of the number of services lead to greater network traffic, making service discovery more complex. Even it's kind of near real-time automation, it will become more complex. Security management becomes critical. How do we define and enforce communication policy between services? And additional communication overhead can result in higher latency and more challenging debugging. So how would you address those challenges? How it's challenged with the service mesh? Sorry. We will focus on key principles actually that help achieving a secure access, including service identity, authentication, authorization, encryption, time-bound access, and audit log. This concept form the foundation of a strong security model and a strong service mesh, ensuring that the only verified service can communicate and all the traffic is encrypted and every request is logged. Let's start with the service identity. The core of establishing trust with the service mesh, like the core. And let's start with identity. The core of establishing trust within a service mesh. In a traditional network, service rely on static IP to address to communicate, which can be unreliable in dynamic environment like Kubernetes. When using a service mesh, every service is assigning a unique identity separate from its IP address. This identity is backed by TLS, is backed by TLS certificate, proven the authenticity of the service. The service mesh takes care of issuing and managing those certificates, ensuring that service can only interact if they can prove their identity. This is prevent unauthorized access and protect against identity spoofing, making it impossible for malicious service to impersonate a legitimate one. Now let's take a look how data move in the service mesh. Unlike traditional network where service communicate directly over the network, a service mesh introduce actually a proxy, that sits between every services. Instead of like let's say service A need to communicate directly with the service B, all the traffic flows through those proxy, and those proxy are responsible for managing, shaping, and securing communication between the services. And Consul-Envoy is the proxy used to handle traffic. This means that every incoming and outgoing request is intercepted, allowing the service mesh to enforce the policy, apply security controls, and monitor traffic. Because all communication is handled by the proxy, we can introduce authorization to control which service are allowed to talk to each other. Traditionally, authorization was enforced through firewalls that allow or deny traffic based on IP addresses. But in cloud-native environment where services are constantly scaling, IP-based rules quickly become outdated and unmanageable. Instead of relying on IPs, a service mesh enforces service intention, where policy determine which service can communicate, rather than saying it's allow traffic from IP, let's say 100 something to IPY. We define rules such as allow search. The phone set, let's say in example here, in my example, let's say a service search can communicate with a service shipping, or service search can communicate with payment. And those actually those intention kind of have the authorization based on the identity of the service itself and not the IP. Once we have authorization in place, we need to secure every communication channel with authentication and encryption. The service mesh automatically distributes TLS certificate to each service, ensuring that those TLS certificates for identity, ensuring that only trusted service can communicate. When one service wants to connect to another, the proxy exchanges those TLS certificates, verifying their identities before any data is exchanged. This process, called mutual TLS, and ensure that the traffic is encrypted end-to-end, preventing unauthorized interception or tampering with the data. This means that even if the traffic is intercepted, it means unreadable to attackers. To further enhance security with the service mesh for time-bound access by actually ensuring that the TLS certificate don't last indefinitely. Each certificate has time to live, TTL, meaning that it will automatically expire after a set period. When a certificate reaches its expiration, the service mesh Consul service mesh here automatically renews and distribute, eliminating the risk of long-lived credential being exploited. This is actually exploited, and this continuous rotation process the stringer of security by ensuring that credentials are always fresh and up to date without requiring manual attention. Beyond authentication and encryption, an audit log and observability play a crucial role in the secure access. The service mesh provides a full visibility into service-to-service communication by logging every request, including details on who accessed what and when. Security team can analyze this data to detect anomalies, investigate unauthorized access attempt, and ensure compliance with security policy. This level of monitoring not only helps detect threat, but also simplify troubleshooting when we have an issue, and making the system more resilient. Now that we covered how service mesh secure communication, let's take it a step further by integrating HashiCorp Vault. Actually, Consul is already actually a powerful tool, a powerful service discovery, service mesh, and identity based. But when integrated to HashiCorp Vault, we unlock even greater capabilities, enhancing security, automation, and centralized certificate management. One of the most important enhancements of Vault is as a certificate authority. By default, Consul comes with a built-in CA for issuing TLS certificate, but for enterprise-grade security, we integrate Vault PKI engine. That allows us to generate, sign, and manage TLS certificate in centralized and more secure way. Vault ensures that certificates are issued by trusted authority, allowing organization to enforce stricter policy and while keeping full control over there. Another key improvement is time-bounded certificate and automatic rotation. In traditional environment, long-lived certificate can become security risk if they are not frequently rotated. With Vault, all TLS certificate issued to the service come actually with a TTL. When a certificate is about to expire, Vault, the same thing as the built-in CA and Consul, it will actually dynamically renew it and distribute it if to the Consul proxy, ensuring that the communication, it will be always secure and there. This is kind of remove the operational burden of manual certificate management, and also actually divide and conquer, that you have Consul and you have Vault. If you have dedicated team that run on this security and have access to Vault, they can do the automation, and this is that the people that manage in Consul actually don't have the ability also to manage the certificate or have any security flaws here. By integrating Consul with Vault, we move beyond basic service mesh security, enabling fully automated, identity-driven, and scalable security for microservice communication. This is combination strengths actually secure access by ensuring all service authenticate dynamically and all traffic is encrypted. To finish and to summarize, to wrap up things, let's summarize what service mesh provide. First, it ensures secure communication between service and integrating mutual TLS. This is mean that all the traffic between services is encrypted and authenticated. Next, it uses sidecar architecture. Instead of service communicating directly, all the traffic flows through the sidecar proxy such an envoy. This proxy transparently manage inbound and outbound connection. And finally, the service mesh enforce access control using service intention. Instead of managing a firewall rules for AP-based security that can grow and be unmanageable, it allows identity-based authorization. And like if you have 10 replica from one service that have the same name with 10 different AP, it's going to be one rule instead of 10 of them. And it can manage actually, it can scale automatically whatever new service is coming up, ensuring that only approved service can communicate. With this capability, a service mesh provides scalable, automated security for microservices, enabling secure access networking with minimal operational overhead. The last piece, actually, the last functionality of a Consul itself is Consul-Terraform-Sync. It's a service-oriented tool for managing network infrastructure near real time. CTS run in daemon and integrate the network topology maintained by our Consul cluster to dynamically secure and connect services. Personally, I found this actually functionality or this feature from Consul very actually useful, since not all the client I work with or the company I work with that use Kubernetes, if you still have mainly working with VMs, load balancer, this actually feature is very important. And before actually working to automation, like before actually deep dive to that, updating or scaling an application was manual process actually that required human intervention. When an application needed more resources, team will receive, let's say, a request. You're going to create the request, like either email manually, Teams, Slack, and to update a new pool service, actually new pool of server or update any firewall. The problem there is no centralized tracking. Like there is companies that have two-way of communication, no request, probably direct request, super request, and this all actually there is no centralized tracking. And updates were actually rarely reflected in the original documentation. This led to delays and errors, sometimes an issue and production issue. This is where Consul-Terraform-Sync comes in. Instead of relying on emails and manual updates, CTS enables real-time automation. When a service registered to Consul, CTS continuously listens to any change. The moment the service is added, updated, or removed, CTS automatically triggers Terraform, which provision and update the necessary infrastructure. This means that whenever service change, firewall, load balancer configuration are automatically adjusted, eliminating human error and reducing operational overhead. No manual intervention is required, which is one of the major enhancements in security, because it's like kind of real time. There is no actually there is no like 2 minutes, 3 minutes, or 1 hour for the request to be done. There is no process, it's automatic. With CTS, infrastructure is always in sync with the latest state of service registry, ensuring that applications scale dynamically and securely. This shift from manual operation to fully automated workflows enables teams to focus on innovation rather than the repetitive tasks. Let's take actually a deeper look how CTS works and the benefits it brings. Imagine you are managing a cloud-based infrastructure while multiple services require a different level of access control. For example, let's say here microservice 1 need to communicate with microservice 3, but only under strict security rules. Similarly, the database layer should be only accessible by certain backend services prevent unauthorized access. To enforce this policy dynamically, we use Consul with Terraform to manage firewall efficiently. How it works. Now let's understand the automation that is needed, like how Consul-Terraform-Sync works. CTS rely on Consul service catalog to track real-time services in a service register. Whenever actually new device is added, removed, or updated, Consul immediately actually reflect those changes in its catalog. CTS continuously listen for these events, ensuring that infrastructure remains synchronized with the actual state of service. Once a change is detected, CTS pull service information from Consul catalog and dynamically generate actually a new Terraform manifest. This means that instead of waiting for manual intervention, CLS automatically trigger the Terraform run, apply the required changes. Those changes could be include actually updating the configuration load balancer, modifying any firewall, adding new DNS, adjusting DNS record to reflect like the new registered services. With this real-time automation, teams are no longer need actually to manually update infrastructure. CTS ensures that changes in the service environment are instantly reflected in the infrastructure, allowing service to scale and secure and adapt dynamically without human intervention. Next, let's explore how CTS integrate with Consul Service Mesh and Terraform to enable end-to-end automation. Here is an example actually of a small task. The task is an automation that you create. Let's say actually to add a DNS, to update the firewall. Always you have the same recipe, you're gonna create a task. This configuration, let's say an example here, define a firewall policy for front-end service or microservices one actually, and how to communicate to microservice two. Let's decompose it. Actually, the most two important pieces here actually, which is the provider. Like the provider specify which Terraform provider I use it to this task. And here, let's say for example, we have Consul and we have null. Null is sometimes used for debugging. This is like example, like a real example we used. But I switched some data on it. And the module is like the code is what is the like reusability. The code is referred to Terraform model that contain reusable logic or for actually define the firewall policy. This allows actually that using reusability, meaning that the same model can be applied in different servers without duplicating code actually. And the third is the condition. The condition is dynamic service rule. Define the conditional policy in the service, which is the names of the service. Let's say is microservice 1 and microservice 2. Instead of IP, the service can have multiple replica. Whatever actually any new replica spin up in Consul, that CTS will pull up that configuration. It will update it. And how work in practice is detect a new update, apply actually Terraform. Here in this example, it will apply the firewall policy dynamically and the firewall is updated. This feature, as I said, is powerful, like automated security, no need for manual update, firewall rules, dynamic update, Consul track the services, and it's very scalable. Actually, you code it once, it can run in one or n machine, and it can be 100 to 1,000. Actually, since Terraform, it will be there. And this is actually add actually to make it things auditable, like Terraform keeps the history of change, helping with compliance. As I said, actually, this is one of the powerful tool actually that I think company can use when they are not actually Kubernetes heavy or actually just to still have actually a managed load balancer or actually have a huge list of firewall rules. I think like through this talk, I trying to explain the three use cases actually for service mesh, CTS, and service discovery, and how actually you can use them, how the theory behind. By using Consul, Vault, and Terraform, actually you can achieve a dynamic identity driven security like that actually scale. And this is actually the shift from the old way to the new way. Everything is automated and actually repeatable and reusable, I mean. Thank you for your time. I will be hanging out actually. Please feel free to ask me any question.